Welcome. It's nice to see so many faces here today. This is the famous wall of meat that I've heard so much about. Like you need climbing equipment to get to the top. I'm going to talk about how to do a million things at the same time. It's going to be a dive into the architecture at King and the technology, and how the technology and the way we operate, the way we look at code, how we deploy it, how that helped us to become so successful in the gaming industry. So when you leave this room, hopefully you know a bit about the technology and a bit about how we work in order to operate this thing. Who am I and what do I do? My name is Marcus Walter. I'm a principal engineer at King. I've been there for a bit more than 6 years now, here in Stockholm. During that time, I worked mostly with game servers, or I should say, the shared technology the technology that is shared across all our games. So it's game servers, databases, caching, data streaming platforms, real-time analytics, quite a lot of stuff actually. But before I start with the main presentation, I have a request to you, the audience here, and as a thanks for coming here and showing interest in what I do. I enjoy interactive talks much more than me standing here for 40 minutes having a monologue. I do like when you ask questions. So I have a bag here full of King stuff. So whoever asks a question, you can come down here afterwards and you can grab something from that bag as a thanks. Before you start, I'll be the judge of relevant questions, right? It has to be attached to what I'm talking about, like technology, yeah, stuff like that. So, go ahead.
No, what happened if we don't ask a question?
So I asked the organizers of JFocus if I could just throw stuff at the audience. That would be much more rock and roll in my sense. But he was a bit hesitant because he's been at a presentation where he actually got a beer can opener in his forehead, and that wasn't really appreciated. So we'll see at the end how many questions I get, how much stuff I have left, because I don't really want to carry this with me all the way back home again. All right. Lost track. What we do at King. All right. So, raise of hands. How many of you know that you have played a King game at any point? That's pretty good. I would assume that around, on an average, I'd say like 10% of the world population has at some point played one of our games. So we're pretty big. We're mostly known for our casual games, like games you play on the tube or when you're waiting for your washing machine to finish. We have brands that you probably know about. Candy Crush is pretty big. We have Farm Heroes, Bubble Witch, just to mention a few of them. We were founded in 2003, so we were coming up on our 16th birthday. Yeah. With that said, we're a pretty big company right now. We have offices here in Stockholm, Berlin, Barcelona, London, just to mention a few. And we're nowadays also owned by Activision Blizzard. So it's Activision, Blizzard, and King. So to put this presentation in a bit of a context, I thought I'd talk you through briefly the King story. It gives you the background, how we came to be where we are today. The King website, king.com, was once one of the 100 largest websites in the world. We offered casual games, pretty much like the ones we have now. You can play them in your browser. We also offered our games through portals like Yahoo and Amazon. Then something happened. Facebook came along. So our players abandoned our partners, basically. So they offered games through their platform and basically ruined our business. King persisted. We tried out a few games on Facebook, and then we launched a game called Bubble Saga. This character is not actually invented in Bubble Saga, but the continuation of that story, she is one of the characters. And that was a huge success, Bubble Saga. All of a sudden, we had millions of players again. So that became our strategy, basically to take games off our old website and offer them on Facebook. And we did that for a while. It was pretty good. Everything was doing all right. And then enter something we now call the Candy Crush incident. So Candy Crush had been around on our website for quite some time. And then let's pick this because it seems to be fairly popular on our website. So we took that, put it on Facebook, and boom. All of a sudden, it went viral. And with the consequence of that was that our systems started to burn. Servers crashing, anything that could break did break. Hardware, like infrastructures, network, software, anything. It was complete chaos. So the first few years of my time at King, we just spent basically firefighting. But that's a good thing, right? We had nice problems. But the thing is that the context of this presentation, that in hindsight, if we had worked in another way, if we hadn't had the technology to support our way of working, we wouldn't have been where we are today. And I'm going to step a bit out of line here to argue that maybe King wouldn't even have existed if we had worked in a different way, or we didn't have the technology and the people to support fast iterations and being able to adapt and keep up with the ever-increasing number of players. So how did we do this? How did we organize? What do our architecture look like? So as I see it, there are 4 pillars to this. First of the ones are technology alignment. So I'm going to talk a bit about that, what our architecture looks like, and what I mean by alignment. The second bullet is freedom. The third one is mandate, and the fourth one is ownership. So I'm going to spend a bit more time on technology and a bit less time on freedom, mandate, and ownership. And then I'm going to, if we have the time, dive into some real-world examples. So I'm going to start with the technology and then go on. So from a technology perspective, it's quite interesting to throw out some vanity numbers. It's always fun. I don't really think that you in the audience might not be aware that the scale of the things that we do. So I'm going to do this. We have 70+ million daily users on our platform. 1.4 billion games finished per day. Our games are web-based, so that's HTTP, request response. And we have 600,000 HTTP requests per second to our web cluster. 1.1 million SQL queries to our database clusters per second. And for our data intelligence pipeline, we produce events. It's a piece of data that about something that happened in our game. We produce 60 to 70 billion events per day that we crunch through our data intelligence pipeline. So it's a pretty big thing that we're doing. So technology alignment. So I'm going to start with a bit of a story here. Have you ever heard the urban myth about the Russian space pen? Yeah. So the Russian space pen, it's not actually true, but it's fun anyway. It's about how the Soviet Union and the Americans during the space race in the 60s tried to come up with a pen that would work in zero gravity. So the Americans, that they spent millions of dollars of taxpayer money on a ball pen, which was a gas-driven thing. Whereas the Soviets, they gave their cosmonauts a pencil. And that's pretty much how I look at the technology at King. We don't do anything fancy. It's not really hard, anything. It's super simple. Of course, if you look at certain select parts, it might be, this is pretty tricky and so forth. But on high level, it's pretty simple. It's nothing that I haven't done before at different companies. The thing is that it works. And it's simple. Things break, but it's still running. And across the whole platform, it's pretty much aligned. Everything looks the same. On the back end, it's 99% Java, a bit of open source, but very much homebrew. We built the system ourselves. We're very protective about our technology. We tend to like to have control of stuff. No legacy. So with that I mean that, for example, we're even scrapping the servlet specification because it tends to block us in certain aspects. We're throwing out the HTTP server that we had for years and basically building one of our own just to have more control over what's happening. So control is one thing. It's simple. So we build on this, and we learn from our mistakes and evolve as we go, and as fast as possible. And when I talk about simple, this is what I mean. This is basically how it works. So you have a client, and you have a server. And you have certain parts that are game-specific per game. And then in the foundation of this, you have shared technology, both on the client and the server. On the server side, the shared technology provides super simple APIs to integrate with the streaming platform, databases, caching, and so forth. So this is pretty similar to any other system that you've probably seen 1,000 times before. The thing is here that within a certain format, it makes it super simple for games to develop their game, for game developers to implement their games. So this is a zoomed-in view on the server just to make it even more clear that there's a very well-defined contract for the game developers to interact with. You basically are not allowed to do anything with the databases without going through the layer of the shared technology. You can't do anything with the caching layer without going through the shared technology. So we have basic control over everything that the games do. So the bottom line here is that it gives the shared technology control, and the games, they have the freedom to do whatever they want to do and focus on building great games rather than spending time thinking about how to talk with the database in an efficient way and being able to provide that service to millions of players. So how do we do this? Are there specific pieces from the technology that are more interesting to make this successful? Yes, there is, and I'm going to mention a few of them. So first of all, storage, and I'm talking databases here. Databases are traditionally something that kind of blocks systems from doing stuff. You're talking to an external system and it's blocking up the thread that's supposed to do some business logic. So this is quite important to make this as performant as you can. At King, we use MySQL. It's a well-tested and battle-proven piece of technology. But the thing is that we use MySQL as a key value storage. We don't do any joins or any other fancy stuff. We have basically all our tables in MySQL look the same. We have a column which is an ID. We have a column that is basically a byte array, and then some metadata, last updated time, and so forth. The key is almost always a string, and the value would be a JSON string stored as a gzip byte array. So this works in the way that we have an object representation stored in the database. We read it from the database into the runtime, the Java runtime, deserializes as a Java object. We query that, mutate it, and store it again if we need to. So this makes it super fast, since we basically just mostly do reads from the database, and the objects stored there are not that big. It's super efficient. We shard our databases, and we usually use the user or the player ID as the key for where this data is stored. This means that as a Candy Crush player, all your data is stored on a specific database shard. So usually what happens is when you do a request and you need to access some data in the database, we'll look up in a specific table, where are you located, and then we go away and read that data from the specific database. This is not the optimal way, of course, but for legacy reasons, this is how it looks. You could have had a consistent hash algorithm for calculating where you're located. This is not the case, unfortunately. So, look up the shard for the user, get the data for the user from the shard. And this has helped us enormously. We have a lot of databases. I don't know, like hundreds. And we are constantly adding or removing databases as we need. Yep. Yes. So that's one of the problems, I'd say, with this, is that you get... oh, sorry, of course. He was asking a question if you can migrate users between databases. And my answer was yes, we can. Because one of the problems with this setup is that you get uneven load on the databases for various reasons. For example, if you have different generations of hardware, perhaps, or you have, okay, we launched this game, it was super successful, and it just happened to be so that all those users ended up on one or a few select databases. So yeah, we support that scenario as well. So you can migrate migrate users between databases. It's quite important. Then there are a few other patterns that we could utilize to make it more efficient, of course. Yes?
Why do you use MySQL instead of a real key value database?
Yeah, Sure. I was expecting that question. So there are a few reasons I'd say. It's first of all, when we started up doing this, there were basically no alternatives, and we had a lot of in-house knowledge about MySQL. And as it turns out, it's super performant. It's InnoDB, which is the database engine here. So what actually happens in the end is that most of the data is cached in the InnoDB cache. So it's super fast. Oh, sorry, maybe you didn't hear the question. Remind me to repeat the question. Okay, storage. For a game developer, we provide a super simple Java contract for interacting with the database. So basically, this is a typed contract. You set up something that you want to store a Java object, basically. So you have basic methods for getting that object. You have a special case for storing. You can do multiple queries and so forth, or asking for sets of these objects. And the implementation of this contract will automatically create the table if it doesn't exist. And take care of everything. So for a game developer, it's super easy to set up. We fail fast through throttling. And throttling in this case means that we have a few methods of monitoring the databases as we go along. One of them is we constantly measure the response time of the read time to the databases. And if something goes wrong, you have something that's happening with the database, it doesn't feel good. Then we more or less block access to that database. So we only allow one thread per game servers at the time to access that database. Which will give it time to recover. Of course, this will cause some problems for the players because any player located on that database might not be able to play at the time, but that's a trade-off that we're willing to take because it's only a small subset of the whole population that's located on that machine, on that database. So rather than waiting for the database to respond, we fail fast and try to fix the problem. Next thing, caching. Super important. We implement basically two types of caching. We have in-memory caching, and then we have distributed memcached setup. So since like the bulk of our data is key value, it's super simple to implement this. In memory, it's just a Java hash map or a Java map. And memcached, it's the same. It's client-side load balancing with a consistent hash algorithm that spreads the keys across the cluster. And this is proven to be very successful because it offloads our servers, our databases quite a lot. And once again, this is super simple for the games to use. It's set up programmatically, so basically when you create your typed contract for the database storage, you can wrap this in caching, various caching layers. You can do it in memory, you can do it in memcached, or you can do it in both. So what usually happens is when you read something for the first time from the database, it will end up in the cache, in the memcached and in the in-memory cache. And I don't know, 90% of the things that we do is read stuff. So everything ends up in memory on the game servers. So we're basically offloading the database machines, which gives us an extremely low latency to respond to the client. Client communication. So this is super simple as well. We use HTTP in most of the cases. We have a few odd things that we do, but like the big games, it's HTTP. And we use JSON RPC for carrying the semantics on what logic to invoke on the server side. So we have a servlet endpoint that exposes anything that from the client want to call on the server side. And as a game developer, what you basically do is you define your game logic as a Java interface. And then you tell the shared code, this is what I want to expose as a client endpoint. And ta-da, it's there. What JSON RPC also gives us, or JSON, should I say, actually, because as I told you earlier, JSON is what we use for storing stuff in a database as well. It gives us data compatibility. It's the protocol that we use for serializing and deserializing objects. Objects can be upgraded to a new schema on the fly, basically. So missing fields in a Java or in an object that carries data across the wire. So missing fields are null, 0, or false when read. And missing fields are ignored, basically. It's, once again, super simple, human readable, and for all our purposes, it's a perfect fit. Load balancing. Like I said, this is a web-based setup. It's HTTP. So we use session affinity, stickiness. So basically what we have on top of all our game servers is one huge load balancer that routes the request to a specific game. And upon the first request, we set a cookie on the client, which will stick or consecutive requests from that client will end up on the same machine. Which also means that once we have read all the data for that client into memory on that machine, we rarely need to go to the database again, unless we're actually mutating something and storing it again. Servers are also stateless, meaning that there are no in-memory states for the game on the game server. So we can add machines, we can remove machines whenever we want to, which makes it super flexible. We can basically expand the cluster as we want to, or remove servers if we have redundancy, or too many machines. So this is what it looks like. We have a client, we have a load balancer, we have a game, we have some cache, and we have a database. Super simple. Yeah.
To what extent are you having multi-user games and single-user games? Because
This is single user. Yeah, most of our games are. Sorry. Good for the thanks for the reminder. You get an extra giveaway afterwards. No. So the question was, to what extent do we have any multiplayer games, right? Yeah. So no. Most of our games are single player. We have some social interactions through our social graphs like Facebook and so on, but most of our games are single player. Yeah. We have a few that are multiplayer games. The ones we have right now are WebSocket based, so with a bit of tweak, it basically looks the same. One big difference for the multiplayer games is that they're much more latency sensitive, right? So we have a few things that we actually run in the cloud. And that is one point I should make, perhaps, is that we run all this stuff on premise here in Stockholm on bare metal, with one catch there, that it's that we're building a cloud of our own at this point.
I have a question.
Yep.
Do you have any failover on the database at all? Like, do you have a slave that you can switch to, or you just trust this object?
So the question was, do we have any failover for the databases? Yeah, we have slaves. So we can fail over to the slave when we need to. So that means also that we have a lot of database servers, of course. I think right now what we're doing, so we have 2 database instances per machine or something like that. So basically keeping the data small enough to be able to replicate as fast as possible. So super simple. Client, load balancer with session stickiness, we have a game, we have a cache, we have a database. Games are stateless. So this is what we can do. It's horizontally scalable. We can add, as clients come, or new players enter the game, we can add servers. We can add more cache, more memory, and we can add more storage without too much hassle. So historically, we've done this by adding new hardware. And there's an internal joke at King that back in the days, like 5 years ago, the biggest bottleneck in terms of scalability was actually unboxing machines fast enough for them to enter the server rack in Akalla. True or not, it's a funny story. So servers in an ideal world should be limited by CPU. The caching layer, the memcached layer, should be limited by memory. And the database should be limited by storage. This is, of course, an ideal world. We have in-memory caches in the game, so there might be memory limitations in the end as well. And this just gives us speed. We can actually add servers, remove servers super fast. And in conjunction with the like the deployment system that we have at King, which is a bit outside the topic here, but basically for us to release a game and deploy it on a new machine, it's a matter of minutes. Yes.
The game logic, when you play the game, is that on the server, or does the client do a lot of the...
So the question is, the game logic, or the actual game, is that mostly on the client side or on the server side? Am I correct? Yeah. Okay. I'd say that it's mostly on the client side. It mainly depends on what type of game you're building, right? So if you're building the type of games that we're doing, which are single-player stuff that you only do on the client, it's pretty safe to run the whole logic on the client, and the only thing you do is storage, or some sort of complicated logic, or maybe you want to send a message to Facebook or something, then you go through the servers. But if you're building a multiplayer game, then you'll all of a sudden have the issue of competition, right? So you don't want people to cheat. So we have systems for that as well, but it's pretty far outside the topic, but it's much more complicated in that case, yeah. Technology alignment, yeah, right. So, super simple. Remember the Russian space pen. This is not rocket science. If the bird flies into the jet engine of the plane won't go down. Of course, we'll have some sort of problem, but we'll fix it, right? It's super simple. We have a fire alarm going off. No, not anymore. Okay. Aligned. So basically, everything looks the same. On that picture I showed earlier, where we have like the servers and the games, the bulk of the code for the servers are the shared code. It's very little code that is required to implement the game on the server side. And it also gives us the flexibility or the knowledge to know exactly what how the system is behaving as a whole, because it's not that much difference between different games. It's elastic. We can add servers, we can remove servers, we can add databases. And it's very, very flexible in that sense. Just add resources as we go. So this is like the technology side of things. This is how it works in order to give us the speed and the flexibility that we need. So how does it look on the other side, like the development side of things? how do we work with this? How do we operate this on a daily basis? Which is also key to the success. Oops. I'm missing a slide here. All right. No, I'm not. Okay, sorry. Freedom, super important. So, as a developer at King, you're giving a lot of freedom. So, for the shared code base, or the shared server code base, I'd say, we have an internal open source culture. So, basically, the Git repository that contains the bulk of the code, it's free for anyone to push to that repository. You don't need to do a pull request if you don't want to. There's no, you need to authenticate. We need to know who you are, but it's not locked down. Maybe for a tester or perhaps a product owner, this is a bit scary because you basically don't know what is running in the live environment. But the upside of that is that you give the developers freedom. And if you give developers freedom, in my experience, I'm a developer myself, they will take responsibility. They will feel that this is my baby. So if anything breaks, I will happily rush to help out with fixing that problem. You get a lot of things for free. You also get the speed for free. We always have developers that are happy to help out, fixing problems, coming up with new ideas. A lot of the stuff that's running live is an idea that some developer had, and there was no one telling you that him or her, that you can't do this. They just went ahead and did it. So we treat all code as open source. Or we try to. At least I argue for it. Anyone can contribute. So if you want to do something, just do it. I encouraged it. 3 and 4 here, mandate and ownership. So as I said, we give everyone the mandate and the ownership, and the ownership will come automatically. You could argue that a more traditional setup with more control gates and watertight halls between different departments might give you more control of the system, maybe less bugs or so, but I've been at those companies before, and I'd say that I much more prefer this because it gives us the speed, and it gives us a sense of ownership. This is my baby. We're all doing the same thing here. We don't point fingers, and we don't blame anyone. If something breaks, fix it fast, fail. Roll forward, don't roll back, because we have the speed. And once we have the speed, we also have something else. We have a very small change delta in the live environment. So we almost always know what's wrong. So this is something that changed. This is probably why it's breaking at the moment. Let's look at that. And everyone helps out. This is key. This is super important. Yes? Very little. Sorry. Sorry again. How much do we rely on test automation? Very little. No, we deploy with care in the live environment. I'd argue that we continuously integrate and test our system in the live environment, and that's the only way to do it. It's a bit scary, yeah, but it's also fun. You know, when I started the King, we had the policy that during the first day, you would push something or commit, back then it was Subversion, you would commit something to Subversion that would go into the live environment the same day. I think that we still have that policy on certain parts of the system. I for sure do encourage it because it gives you the feeling for the speed that we're aiming at, and it gives you the sense of freedom that you want to contribute as fast as possible. Yes? So, how do we run A/B tests? Without going into too much technical detail on that, we have systems that support that for us. So basically, we can divide parts of our user base into different test groups, control groups, and easily assign them through a certain algorithm on the server side that you can either run this or that case. And we can even do, of course, changes in the user interface on the client, but that requires more time. So that's usually what we use the A/B testing framework for. If you do something on the server side to test different behaviors or different things on the server, it's usually not an A/B test. It's just we want to do something. We test technology in a rollout scenario, so we can do for a certain amount of the requests or the processing power that we have. We test this, but it's built into the system, and it's a bit out of scope. It's quite a big topic. Okay.
What sort of statistics gathering do you have to see how people are using the game so that you can know how to improve them?
All right. So the question is, what type of statistics gathering do we have in order to know what our users are doing? Are you referring to both like the technology or only how users are behaving?
The end users, the people who are playing the games.
Oh yeah. Okay. So we have. So I mentioned that briefly in the start that we produce a lot of events from our games. So an event at King is a small piece of data that carries the information on something that happened in the game. It might be you purchased something, or you didn't complete this, or you failed at this level or something. Those events can be generated both on the client side and on the server side, and we push them to our data intelligence or our data warehouse, where they basically materialize as tables. And then we have smart people who query them. It's, from a technology perspective, quite simple. They end up as tables, and then you can do queries on them, joins between them, and see what happened over time or at a specific, whatever you want to look for. Yes, we have a question. Yep.
My question is, do you have a way, do you need it at all to search for a specific property in a JSON object in the whole table? How do you do that?
So
Is that you load everything to the cache and then search, or is there another way to do it?
So the question is, how do we interact with the deserialized JSON objects that we store in our database? Yeah, more or less. So we tend to store small pieces of data. It's not like we have one big piece of JSON per user. It's usually per use case, I'd say, or something very specific. So the piece of data is very small. So we just read it from the database, store it in memcache, store it in memory and machine, and then we can use it as a Java object.
The JSON object will be only one or two fields inside the JSON object. It will not be more than that. And then if you need to filter about the field.
I'd say the question is how many fields or so do we have in these, or is it just one or two or more? 4 or 5 fields. No, we try to avoid nested objects, like we don't have complex. We only use primitives in those JSON objects, so it's not that you have to traverse a big tree of things to find something. It's lists, strings, integers, and so forth. Nothing more complicated than that, and that has been our approach from start, since we had data compatibility issues between different languages on the client side, because this JSON might, in the end, also end up on the client side. So, for example, we had ActionScript clients a long time ago, and they don't support certain types of primitives, basically. So we had to be very restricted restrictive in that case. Happy with that answer? Okay. I have 5 more minutes. I need to speed up. Okay.
It means that you don't join, I mean, you don't look for, I mean, if you have like, in the same object, you have let's say, the name and the family name and I don't know what.
Mm-hmm.
Okay? So if you want to search for all the people that start with the family name F, you don't do this type of.
So the question is, if we want to search for example, anyone named Marcus in our set of or in our population of players, how do we do that? And the simple answer is we don't. We don't do that. There are other ways of coming up with the similar functionality. For example, if you want to present big lists or top lists of stuff, if you want to have people named a specific way, we can always cheat the player to give them the impression that we're actually doing something much more complicated than we're actually doing. There are things to come around those issues, but we don't do that type of no range queries, no joins. What about GDPR? What is there not to talk about GDPR? Maybe I should do a talk about GDPR. GDPR has been 1.5 years of coding, but we're compliant. Yep. Okay. So mandate and ownership. We encourage people to contribute. We are clear about responsibility, no pointing fingers in any way, but if you're giving the freedom, we also expect you to take the ownership of things that you do. And with that, we also get a lot of things for free. And the bottom line is that we get speed. Speed in development, speed in deployment, and everything, which is super important. Without this, King wouldn't have been able to evolve fast enough to handle the massive increase of players that we had a few years ago. And I think that this is something that everyone in the end wants. I totally acknowledge that we are in a special business here. There's like no one dying because Candy Crush doesn't work. Maybe you are, but I'm not. But we don't have any laws that control what we're supposed to do. But if we can, I think this is something that everyone wants. So I need to speed up. I have like 1 minute left. So for example, this is how do we do a release? So we have the shared code. We release that as often we can, several times a day. I don't know, I could probably come up with an average about 5 times a day. At any point in time, this release might be picked up by a game team, and we basically don't know when they go live. But it's okay to fail. We do that. Fail fast and fix it fast. Do this as often as you can. Keep the change delta small, and it's easy to spot, easy to fix. And since we have the speed, it's also easy to fix it and roll forward rather than rolling back. Yes?
When you do releases, do you release over the whole cluster?
No, we usually release per game. We have an internal server inventory system that keeps track on what machines belong to which game, so we can target specific releases. We also have, if we release big games, we don't do that with too frequently, or we don't do one release and too soon another release. Rather fall forward than back. Yeah, that's also one important point that I wanted to make. So how does this look like in the real world? Do we have a real world example? And I'm gonna skip a few slides here and just do the fun stuff. Fun-driven development, that's fun, let's do that. So, fun-driven development, we're out of time. Okay, this is it. To do stuff that you think is fun. doing stuff to do stuff that we don't think is fun because it's on the to-do side of things. Doing stuff that we think is fun because we're actually doing it. On hold, stuff we thought was fun, but we moved it to on hold because it's no fun. Blocked, that's stuff that someone else does not think is fun, so it's taking forever, it's blocking us. And done, stuff that was actually fun. So this is something that we do, or at least did, in the team I was in, because we were very much interrupt-driven by being forced to keep the live environment live at any time. So this is the working model that we came up with. And now I'm going to skip to this. Takeaways. Keep your technology simple and aligned. Give your developers freedom. Trust your developers to do the right thing. Fail fast, fix the problem even faster, and given the mandate and the freedom, this will come for free. Without this, King would not have been where we are today. Thank you. And yeah, for those who asked questions, come and receive your reward.